As promised, ladies and gents, this is your second cheat code for buffer calculations. So the first one, if you missed it, go and check it out. It's where we create a buffer using a weak acid and the salt of that weak acid. So we're literally just mixing the two components together that we need for a buffer, and then we can use those values to calculate the pH of it. This is different. This is the second way we can create a buffer, but this time we're reacting a weak acid with a strong base. Now, the first thing you need to realize is that when we react a weak acid and a strong base, neutralization is going to happen and we're creating a salt and water. The second thing you need to realize is that in any of these questions, the weak acid is in excess. Why? Because when these two things react together, all that strong base is going to get used up, and then all we're left with is whatever the excess weak acid is and the salt of that weak acid. So don't forget, the weak acid is always going to be in excess in these questions. So first job, folks, is to find the number of moles that you have of your weak acid to start with, and of course the number of moles of strong base. Now in the question, the information will be there to allow you to do that. So for example, we have got 10.5 centimeter cubed of 0.8 molar sodium hydroxide. So all you need to use is concentration times volume. That's being mixed with 25 centimeter cubed of 0.92 molar HX. That's our weak acid. So all we need to use concentration times volume to find the number of moles of each of those. Next up, we need to write the equation for the reaction between that weak acid and the strong base. I've done it here using the information I've got from the question. HX plus NaOH gives NaX, which is our salt, and H2O. Underneath, I put the initial number of moles that we start with from 0.1 underneath the HX and the NaOH. Next up, we need to find out what's left over after the reaction has happened. I've called sodium hydroxide X here, so the number of moles of HX left over is whatever this number here is minus X, and that will give you this number here of moles of HX left over. Of course, because the HX is in excess, all of that sodium hydroxide gets used up, and you can ignore that now. It's gone. But if it's a 1-to-1 molar ratio between these two things, between the sodium hydroxide and the salt, which it probably is, then you're going to form X moles of salt. So now you have the number of moles of weak acid you have left over after the reaction and the number of moles of salt you've created. Next up, we need to find the new concentrations of HX and the salt because we need to plug those into our Ka expression. Watch out though, there's probably a new volume in town. So you have to add up the two volumes that you've added together. In this case, 10.5 and 25, giving us a total of 35.5 centimeters cubed. And that's what we use for concentration equals number of moles divided by volume. Fourth step, it's Ka expression time, folks. So that is our usual Ka expression. Then your last step here is to rearrange it to make hydrogen ion concentration the subject. Plug your numbers in with using the Ka that was given to you in the question, and then of course you're going to get your hydrogen ion concentration, and therefore you can use that with the minus log to find your pH. So just to recap, your first cheat code was that you're going to get questions whereby you're just mixing the raw ingredients of a buffer using a weak acid and the salt of the weak acid. This is the second version where you get a weak acid, it's reacted with a strong base to create a solution of the weak acid and the salt that reaction produces. And don't forget, your weak acid in these situations is always going to be in excess.